many times can I charge my phone using energy from this cake? We as humankind don't really understand energy, even though we use the concept in our daily life. A piece of cake has enough energy to charge a phone every day for a month. The same energy lifts itself 1,700 kilometers high. This is like 4 times higher than the altitude of the International Space Station. Richard Feynman, one of the greatest physicists in the world who got a Nobel Prize, once admitted, we don't really know what energy is. Richard Feynman said this, not me. So what's strange about our understanding of energy? Well, firstly, we don't know what it is. We can't touch it, we can't see it, but somehow we can measure it with astonishing precision. A cake contains around 400 calories. That's an energy bomb. But do you know what is the smallest amount of energy we can actually detect? We can sense a single infrared photon carrying just 0.8 electrovolts. To put that in perspective, a cake contains 25 orders of magnitude more energy than a single photon. That's like comparing Earth to atom. Physicists love energy for one very important reason. It seems to conserve. And if energy is disappeared, it means that we forgot to account for something. And once we find the missing piece, everything balances again. And that's how many discoveries were made. In the 1930s, physicists noticed that energy was vanishing in a radioactive decay. And since energy must be conserved, they knew there was something wrong. They noticed that something invisible must be carrying it away. And they were right. That's how neutrino was discovered. But 150 years ago, the idea of what energy was really abstract. The story of energy is actually pretty fascinating. It started with Leibniz, who noticed that many mechanical processes depend on mass times velocity squared, what he called a living force. Yet for a long time, heat was actually seen as a physical substance, a sort of weightless fluid called caloric that flows from hot to cold. But the breakthrough came at an unlikely place, a cannon workshop. Benjamin Thompson noticed something that was impossible. If heat was a liquid stored inside a body, it would eventually run out. If caloric existed, it would stop appearing. But that didn't happen. No matter how much they drilled, it never exhausted. So he realized that energy was not a substance being released, it was a substance being produced by friction. In my honest opinion, the idea of something that being unseen and untouched is usually a red flag. Well, apart from dark matter and dark energy, I guess. To be fair, at the same time, 2 scientists came up with the same idea in different fields. It took decades more for James Joule to prove that mechanical work and heat are actually 2 different sides of the same coin. He conducted multiple experiments precisely measuring how mechanical work transforms into heat. Finally, Helmholtz tied it all together into the law we know today, the law of conservation of energy. The irony? Carnot actually laid out the foundation of thermodynamics and engine theory while still believing in the non-existent energy fluids. He built the map of energy without actually knowing what energy is. If you think about it, we still don't know what energy is. All right, so for physicists, this is clear. They make calculations and they see that energy somehow keeps everything consistent. In everyday life, we think about energy less philosophically. We treat it as something that can be converted to work. And dependent on the field, we measure it in different units. Because these units often describe very different scales, it is hard to understand how they relate. For example, if I took the amount of energy needed to warm up a bottle of water and put it into motion, how far would the bottle of water fly? That is so absurd. 1 meter? 2 meter? 5 meters? No, 420 meters. It's like a high skyscraper. Remember this piece of cake? This contains enough energy to lift me 3 kilometers up in the air. So what causes such an effect? The reason is that these forms of energy are defined differently. Mechanical energy has a much lower capacity than thermal energy and, of course, chemical energy. Kilocalories, or simply calories in everyday language, are used for food. They show how much chemical energy is stored in the food that we eat. 1 kilocalorie is defined as the amount of energy needed to heat 1 kilogram, or roughly 1 liter of water, and heat it up by 1 degree Celsius. And remember, E equals mc squared. Since mechanical energy capacity is lower than all the other forms we use, I find it extremely fascinating to translate the energy we consume into mechanical terms. How much kinetic energy does a moving tram have? To give you an idea, this is just about 2 pieces of cake. By the way, this is the same amount of energy that's enough to heat 10 kettles of water. It really shows you how dense the chemical and thermal energy are in comparison to energy of motion. Now, what about chemical energy? It is insanely dense. For example, a glass of fuel contains 2,000 calories. This is more than my entire daily recommended intake. Honestly, I would consider taking it because it's cheaper than food, but they don't offer chocolate option, and it's just carbs, which is not very healthy. Guys, let's make a deal. If this video gets 10,000 likes, I will go to the gas station and ask if they have a banana taste. So that 1 glass of fuel is equivalent to 5 cakes. And what about our phones? Milliamp hours, or mAh, are often used for batteries, for example, phones and laptops. They tell us how much energy a battery can store. Technically, mAh is not an energy unit itself. To estimate the energy, we need to multiply it by the battery's voltage. Well, full charge takes about 15 kilocalories. It may seem like little amount, but the same amount of energy is enough to lift me up 120 meters up in the air. Honestly, I'm really confused about why the producer is so obsessed with the idea of lifting me up today. While I live in the world of calories, science speaks in joules. To lift 1 little apple above the ground 1 meter takes approximately 1 joule. But what about a chocolate bar? It contains 2 million joules. To not do that kind of scary math at dinner, we just stick to calories. Nevertheless, you can still find joules listed on the packaging next to the calories. But let's be honest, who ever looked at them? I never did. Until today. To burn those 400 calories, I have to climb approximately 200 to 250 stairs. This is basically a Burj Khalifa, just for 1 piece of cake. Gravity is an honest judge. It gives us a very vivid and sometimes painful idea of how much energy we actually consume. It's one thing to read a label, and another thing is to understand that this piece of snack is an equivalent of a skyscraper climb. And if you think that's impressive, look at this. A single kilogram of human fat contains about 7,700 calories. Really? To burn that off purely with mechanical work, you need to accelerate 9 multi-tons trams into a city with a speed of 50 kilometers per hour. So next time you're on a treadmill, just think about it. You are fueling an entire city transportation. That just makes it more heroic. Kilowatt hours is the language of electricity. They tell us how much energy we consume in our home, and most importantly, how much we owe to the utility company. Kilowatt hours is how we count money. For example, in my city where I live, 1 kilowatt hour is approximately 50 cents. Coincidentally, this is 860 calories. Just think about it. 2 cakes for 50 cents. My daily intake is approximately 2 kilowatt hours, or $1. Honestly, this is a robbery. This is my second disappointment today after the lack of chocolate fuel. Why can't I simply charge myself from a power socket? Charging your phone every day for a month costs you approximately 50 cents. Science really shows you where the expenses are. So, before this gets even crazier, let's talk about where it all came from. I have already discussed with you that the idea of energy conservation just came from someone drilling a cannon 200 years ago. But the most elegant explanation didn't arrive until 1918, when Emmy Noether came up with the most elegant theory in the whole physics. Here's the full explanation. Looks pretty scary, doesn't it? Fortunately, the core idea is pretty simple. If the laws of physics are the same today as they were yesterday and 200 years ago, this means that nature doesn't care when an experiment is performed, and this means that there must be a substance being conserved. And the substance is energy. Emmy Noether was one of the greatest mathematicians in the 20th century, alongside with Marie Skłodowska-Curie, although her work is often hidden in the deep foundations of modern physics. Her theorem revealed something astonishing. Conservation laws are not just arbitrary rules. They emerge from symmetries. Energy comes from the symmetry of time. Momentum comes from the symmetry of space. And angular momentum comes from the symmetry of rotations. Decades later, scientists noticed that some of the symmetries they thought were absolute were actually violated by a weak interaction. A discovery so shocking it won a Nobel. But that's a story for another video. Make sure to subscribe to see how we break the laws of physics. Stay tuned. Thanks, Emmy Noether, for momentum conservation. Now, for something truly mind-blowing, if you take a single grain of sugar, it weighs approximately 0.1 milligrams. But in nutrition, it is basically half a calorie. But what if we look at this little grain of sugar through the perspective of Einstein's E = mc squared? What if we converted its entire mass into pure energy? The result is staggering. It is 2.8 million kilocalories. That is basically 7,000 cakes. This is enough food to keep me powered for 4 years, and this is approximately 3,200 kilowatt hours. It costs me approximately $1,500 of energy from the socket. That's enough energy to launch 1,750 trams. And going back to our favorite experiment of lifting me up, this one grain of sugar can lift me up 28,000 kilometers up into space. There's one mistake in the video, and if you found it, please comment. So let's sum it all up. A small piece of cake contains enough energy to put something in space. A single banana contains raw power to set a car speeding down highway. At first glance, it may sound like a mistake in calculations, but it's not. It's simply the reality of the world where thermal and chemical energy are astonishingly dense, especially comparatively to the amount of mechanical energy they can produce. We've learned to measure energy in joules, calories, kilowatts, and yet we ask ourselves what energy really is. Is it just a convenient entry in the universe's cosmic accounting system? And perhaps this is the true beauty of physics. We don't really need to know what energy is to be able to use it. With that every bite of cake and with every step we take. Every step we make. This has been the most scientific. Don't let your energy go to waste and hit that subscribe button and let me know in the comments what you found most surprising.